Good day, dear students. Welcome to Chapter 4, Elements of Traffic Analysis. At the end of this lesson, you will be able to, first, discuss traffic analysis, second, identify the variables of traffic analysis, and then third, discuss the variable relationships among the variables that we have seen here. And with this, we are going to cover the introduction to traffic analysis, and then we will cover traffic analysis variables, and then we will look at the relationships among the traffic analysis variables. The primary function of a highway is to provide high level of transportation service and safety. We have seen this in the introduction to transportation engineering. Now, traffic analysis provides the basis in measuring the performance of the highway system. So will it provide the high level of service and safety or not? There are different dimensions used in traffic analysis, and these are the following: the number of vehicles per unit time, or the traffic volume, the vehicle types and speeds, the variation in traffic volumes over time. For example, we have the peak hour volume, and the traffic volume within other times of the day may be lower than this peak hour volume. And these dimensions influence the highway design and operation in terms of the traffic control device, for example, the traffic signals, the signs and markings where the highway needs it, and also the type of pavement and the geometric design for the highway, and how many lanes is needed. Now let's look at the traffic analysis variables. We have three main variables, or what we call parameters, that form the underpinning of traffic analysis. These are the flow, designated as Q, speed, designated as U, and density, designated as K. Flow or traffic flow is defined as the equation 4.1 here. So flow is equal to N, which is the number of vehicles passing some designated roadway during time T. And T here is the duration of the time interval. Time headway is the time between the passage of the front bumpers of successive vehicles at some designated highway point. So for example, if you look at this figure here, when the vehicles are on the highway, then the gap, the headway that we're talking about is the time between the front of this vehicle to the front wheel of the vehicle in front of it. And these are their gaps, and these are the overhang. These time headways are related to T as defined in the equation 4.1 a while ago by this equation. T is the summation of the headway from the first vehicle up to the certain number of vehicles on a highway. Substituting equation 4.2 into equation 4.1, we now have the equation of flow, which is N over the summation of the headway from the first vehicle to the nth vehicle, or in terms of the average time headway, the flow is equal to 1 over h bar, which is the average time headway, and summation of hi over n is in unit time per vehicle. Now, there are two kinds of speed we use in traffic analysis. The first one is the time or spot mean speed. This is the average speed of all vehicles passing a point on a roadway over a specified time, or instantaneous point speed as taken by a radar gun, for example. If you have seen a radar gun on a highway, every time a vehicle passes, then it can take the speed, the running speed of that vehicle. So the time mean speed, UT, is equal to the summation of the speed I of the vehicles from the first one to the nth one divided by the number of vehicles. Now the next speed is the space mean speed. This is the average speed of all vehicles occupying a given section of roadway over a specified time, or essentially the inverse of the travel time for all vehicles over the specified section length. For example, specified section length is 1 kilometer. So you will determine the average speed of all the vehicles occupying that certain section of 1 kilometer. This is more useful in the context of traffic analysis and is determined on the basis of the time necessary for a vehicle to travel some known length of roadway. And then each time a vehicle passes the initial point, then the team member can record the time the vehicle passed that point and the plate number of that vehicle. By then, the team can consolidate how many minutes the vehicle passed the certain 1 kilometer. So if you know the speed of each of the vehicles that pass that 1 kilometer distance, then you can get the average, and then you can use it in determining the space mean speed. So the space mean speed is equal to L over T, where L here is the length of the roadway used for travel time measurement of vehicles, and T bar here is the average vehicle travel time, defined as 1 over n times the summation of the time from the first vehicle to the nth number of vehicles. When you have used 1 kilometer, then this should be 1 kilometer.